Hello there, this is Mr. Benji again, and in this tutorial we're going to look at the median. When working with a discrete variable, the procedure to figure out the mean of a distribution of any given distribution is very straightforward. Okay, let's just take this distribution as an example. Assuming you're presented with this distribution here, a distribution involving 7 numbers, okay? Involving 7 numbers. Therefore, in this situation, the sample size of n equals 7, okay? It's an odd number of numbers. It's an odd number. When n is an odd number, in a very straightforward fashion, all you need to do is to identify the middle number. There you go. This is the mode. This is the median. And of course, with the median, you need to rearrange. Okay, if the distribution has not been arranged in ascending order from the smallest number on one end to the largest number in the other accordingly, if you have not arranged them nicely going from the smallest to the largest in terms of numeric value, you have to do that first. So step 1 is to arrange the numbers in ascending order from the left side to the right side. The second step is to identify the middle number. Here, since the numbers are already arranged in ascending order, the middle number is number 5. Now, another way to double check whether this really is the middle number is to do this. To the left side of the median, how many numbers are there? We've got 3 numbers. And to the right side, 3 numbers. That is to say, the number of numbers that are smaller than the median ought to be the same as the number of numbers that are larger than the median. I repeat, number smaller than the median and the numbers larger than the median, they ought to be the same number of numbers. Okay? They ought to be the same number of numbers. So very quickly, we have just looked at dealing with distributions involving an odd number of numbers. Distributions with an n that is an odd number. And naturally, you should be wondering, how exactly do we determine what the median is for distributions involving an even number of numbers? Now, distributions involving an even number of numbers, let's just take this as an example. We keep the same numbers and we add 1 more, rendering this distribution now not having 7 numbers but 8 numbers. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 8 numbers. N equals 8. Okay, now when the sample size is an even number rather than an odd number, what do? The procedure, step 1, is the exact same. Step 1, again, is to arrange the numbers from the smallest to largest, in ascending order. Here we've already done this. The second step, however, is to identify the middle numbers, plural, 2 middle numbers. Okay? Now, this procedure is unique to distributions with an even number of numbers. In this situation, we've identified the 2 middle numbers, 5 and 6. Why are they middle numbers, you may ask? Well, similar situation as before. So, smaller than these 2 middle numbers, we have 3 numbers. Larger than these 2 middle numbers, we also have 3 numbers. Again, the 2 middle numbers, they are where the symmetry happens. Okay? To the left side, to the right side, smaller than them and larger than them, they have the exact same number of numbers as part of the distribution. Okay? Now, the numbers that we have identified, 5 and 6 right there, here's the following procedure. What we would do is to add the numbers and divide the total by 2. In essence, we're figuring out the average. of these two middle numbers? Are you with me? Okay, well, the average, easy peasy, 5 plus 6 is 11. 11 divided by 2, we get 5.5. So to the question, what is the median of this distribution? The answer is 5.5, right there. Now consider another distribution. Let's just say that you're presented with a distribution involving these numbers. The number 4 and 4. So the number 4 showing up twice. The number 5 also showing up 2 times. And for simplicity's sake, I am already arranging the distribution in ascending order, okay, from smallest to the largest. Let's just say that the number 6 actually shows up 4 times. The number 7 shows up once, and the number 8 shows up once. Okay. Now, how many numbers are there? We've got 10 numbers. N equals 10. N equals 10 in this situation. 4, 4, 5, 5, 6, 6, 6, 6, 7, and 8. All right. Well, to the question, what is the median? Because we've already lined the numbers up, and we know that this distribution involves an even number of numbers. N is an even number, sorry. What exactly do? We will identify the two middle numbers. And if you recall the procedure, we are to take the average of the two middle numbers and divide by 2. Six plus 6 equals 12. 12 divided by 2 is, again, 6. So in the situation when the two numbers are both the same, well, the median is that number itself. Now, here's what's interesting. You need to make a note. This is only true. This will only be true if the information, as the question indicates, is that these numbers, they are a discrete variable. So then what happens when a set of numbers, when a distribution presented, they represent a continuous variable? Well, the procedure will have to be slightly different. When analyzing a distribution of numbers representing a continuous variable, we cannot use the strategy as described so far. Now, see if you can visualize the numbers using a graph, okay? Using a histogram. Let me show you what it looks like. Here we're using a histogram to describe the distribution as we've laid out. So 2 4s, so 4 showing up twice, the number 5 showing up 2 times, 6 showing up 4 times, 7 1 time, and 8 1 time. Keep in mind, our conversation now is to deal with this distribution as representative of a continuous variable. Now, in a situation of a continuous variable, the number 4 represents any entry, represents measurements that fall between its upper real limit and its lower real limit. In a situation of 4, its upper real limit is 4.5, as indicated right here. And the lower limit of 3.5 one way to think of it, one way to wrap your hand around the concept is that numbers with measurements anywhere between 3.5 and 4.5, they would be categorized and counted as in the category of 4, okay, the number 4. For the number 5, it represents upper limits of 5.5, the upper limit of 5.5 and lower limit of 4.5. The number 6 represents entries between the upper limit of 6.5 and the lower limit of 5.5, etc., 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 etc. Okay? So that's the first recognition. That's the first recognition. And graphically speaking, now the median is not as simple as the number 6 because we're not working with a discrete variable. We're working with a continuous variable. What we need to recognize is to pay attention to the volume of these squares. I'm not doing a great job in showing exactly squares that are of equal size. Just make the assumption in your mind that every one of these squares, okay, we've got how many squares? We've got 10 squares here in front of you on this graph as part of this histogram. Every one of these 10 squares, they are of the same area. Okay, they're of the same area. And our goal is to determine at what point on the line, at what point on this line cleanly cuts the 10 boxes into separate sections of 5 boxes versus 5 boxes. Okay, 5 boxes versus 5 boxes. So one way to think about this is to go through the procedure of counting. Let's just say if we begin by counting from the left side onwards, okay, from the left side onwards, 1 square, 2 square, 3 square, 4 square, okay? And on the other side, 1 square, 2 square. Okay, well, what do we do with the 4 squares that are labeled using the number 6? The 4 square label using the number 6. For the number 6 to show up 4 times, 4 squares are involved. And in order to figure out that point on the number line where it cuts the 10 squares neatly into half, that is to say, a volume of 5 squares. In the situation of the red side, okay, actually let me shade them. Let me just shade all of them. Hold on. Now I hope this is clearer. In the situation of the red boxes, we already have 4 boxes, okay, coming from the left side. And the 4 boxes need how many more boxes? Need the volume of how many boxes in order to achieve the number 5? They need 1 box, okay? Now, in order to obtain the volume of 1 box among the 4 boxes, okay, among the 4 boxes that are labeled with the number 6, what we need to do is to cut off a quarter for every of the 4 boxes. Do you see? We need to cut a quarter of the boxes. Again, the idea from the perspective of the entire volume, the median denotes on the number line the point where it cuts the volume of the histogram, of the entire histogram, in half. Okay? So for the red side, in order to achieve the volume of 5 boxes, they would have to cut at this point, okay, with this distance being a quarter of a box, quarter the size of a box, or you can think of the quarter as essentially 0.25. Now earlier we talked about the higher limit of the number 5 being 5.5. So to figure out the point where we cut the entire volume of the histogram into half, this point, what is this point? This point essentially is 5.5 plus 0.25. Do you see? Let us do the math. We get 5.75. Therefore, in this situation, 5.75 is the median. So what I've described so far is the procedure for figuring out the median of a distribution that represents a continuous variable. All right, now can you do it from the other end? Can you do it the other way around? Absolutely. The procedure essentially is the same. The box, the entire square that represents 7 and the entire square that represents 8 right there, they already account for the volumes of 2 squares. Okay? How many of the 4 squares labeled with the number 6 do we need to color in green in order to obtain a total volume of 5 squares? Well, the answer is this. The answer is roughly a 3/4. So we need 3/4 of every of the 4 available squares. Every of the 4 available squares, because 4 3/4. 4 of 3/4 gives us 3. Do you see? 4 times 3/4 would give us 3. And the 3, we add the volume of 3 squares to the 2 right here, would give us the total of 5. Okay, and the procedure essentially yields the same point. It essentially yields the same point. If you subtract here, the procedure now is to subtract from the upper limit of the number 6, the upper real limit that the number 6 represents, which is 6.5. And if we were to subtract from 6.5, 0.75, take a look at what answer we obtain here. We would obtain the answer 5.75, which is essentially the same number. Do you see? Okay. So, conclusion, this is the answer, this is the median. There are decimal places to consider, there are fractions to consider, possibly because the numbers here represent a continuous variable rather than a discrete variable. I hope this tutorial helps. Nothing is in the way for you to rewatch this tutorial and gain further clarity and mastery of the subject matter. More of such will be made available in the foreseeable future. Hit the like and subscribe buttons to stay up to date of quality tutorials that can help you succeed in your studies. You've been watching Mr. Benji at Mr. Benji Now on YT. I'm a college instructor in Vancouver, BC, Canada. Until next time.